So start. Let's start our 24th class on physics optional paper 2. Okay. Now in the 24th class, we will examine one more question. The question says examine whether the following wave function denotes realistic situation or not. So your psi x is basically a e to the power minus kx, okay, for x smaller than 0, okay, and it is equal to a e to the power kx for x greater than 0, okay, for x greater than 0 it is equal to this. Now we know this very well that our condition says that the functions must be finite everywhere. The functions must be finite everywhere between minus infinity to plus infinity, right? Our question says like this, that our function must be continuous everywhere between this. So let us first put minus infinity over here. For x is smaller than 0, minus infinity is smaller than 0. So if you put minus infinity over here, then what will you get? You will basically get a e to the power minus k into minus infinity, which is equal to a e to the power kx. Okay, not kx, into infinity. K infinity means uh, it will be basically your infinity. Okay, not k infinity. We should not write k infinity. E to the power infinity we should write instead. Okay, because anything multiplied by infinity is infinity only. There is nothing called as k infinity. Okay, so e to the power infinity, that in turn is again infinity. So our condition that our that condition is violated. Okay, so that implies that psi of x, and similarly when you put x equal to infinity, similarly when you put x equal to infinity, psi comes out to be your infinity. When you put x equal to infinity, psi comes out to be infinity. You can check, when I will put x infinity, I will satisfy this condition and I will use this equation. So again it will be a e to the power k infinity, k into infinity I mean, and that will be equal to again infinity. Okay, so this is the thing which you will get at x equal to infinity. So our this thing, as psi x is not finite, so even its slope means its differential, partial differentiation with respect to x, that is also not finite everywhere. Okay, that is also not finite everywhere. Okay, so that is also not finite everywhere. Other conditions, no need to check. Okay, no need to check other conditions. As if even a single condition is not satisfied, no need to check other conditions. As if even a single condition is not satisfied, the psi of x wave function will be unrealistic. Okay, psi of x wave function will be unrealistic even if a single condition is not satisfied. Okay, so no need to check other conditions. Okay, so clearly from here, not a wave function for realistic situation. It is not a wave function for realistic situation. Okay, now if you try to draw its graph also in exam, you have to do that. Okay, uh, because this is very general kind of wave function, so you have to draw its graph. Okay, it's a common type of wave function, so its graph will look something like this. Why its graph will look something like this? Because when you will basically go over here up to x equal to infinity, it will be basically your this kind of curve. Okay, which will go higher. Okay, and if you go x equal to minus infinity this side, this curve will be like this. Okay, so it is also, this y is also tending to infinity, or y is equal to your psi of x, so that is also tending to infinity. Okay, so and at x equal to 0, you can clearly note this thing, that at x equal to 0 what will happen? At x equal to 0, psi of x will come out to be equal to a. At x equal to 0, again it will come out to be equal to a. Okay, so your value clearly is this much, it is a. Okay, your value clearly is this much, it is a. Okay, so that's how you could have drawn its graph. And how did I know that this is the nature of the graph? How did I know that this is the nature of the graph? From my JE concept, JE time concept. From my JE time concept, how did I know this? Because I know that graph of e to the power kx and e to the power minus kx, how it looks, exponential graph. Okay, exponential. How does it look like? I know this clearly. So from there, I knew this. Okay, from here, from here I knew this. I mean, okay. So that's the thing. Okay. So let's keep this lecture this much only. I am also feeling sleepy. Thank you very much. Jai Hind, Jai Bharat. And there will be 100% lecture, 100% syllabus coverage. You don't have to worry for it. You don't have to go for any paid course. Okay, these lectures, if you follow seriously, then these will be completely sufficient, provided you are following this seriously. If you are not following this seriously, then I can't do anything. Okay, it will be even better than paid course. Okay, so I can assure you this thing very well.